All right, so we have two division problems up here. This left-hand one, when we're simplifying these little fractions like this is when we kind of split it into two pieces where we have 2x over 2 plus 6 over 2. To simplify it down, 2 over 2 equals 1, so this becomes just 1x, bless you, plus 6 over 2 gives us 3. So for this left-hand one, to simplify it down, it looks like this. For our right-hand one, with our long division, this is when we take the 3, and we see how many times does 3 go into this very first number. All we care about is that first number, the 3 into the 4. 3 goes into 4 one time. Ooh, wrong pen. Then we take that 1 times the 3 and put it underneath to get 3, and we subtract, right? So we have 4 minus 3, giving us 1. And we drop down the 9, and we drop down the 3. Then we start that same process over again. But since 3 doesn't go into 1, now we check into 19. How many times does 3 go into 19? 6. So we have 6, and then we do 6 times 3, which is 18. And we subtract that. We get 13. Because we drop down the, or 9 minus 8 is 1. 3 drops down. How many times does 3 go into 13? 4. Because 3 times 4 gives us 12. We're going to subtract those. We get 1. That's our remainder. Because we can't divide it again. We're not going into decimals. So when we say what is 493 divided by 3, we get 164. And my remainder is 1/3. 1 over what we divided by. Our remainder over what we divided by, okay? Long division is going to come into play today with what we're doing and what we're working with. So questions on any of these or any of these steps? But I know it's been a hot minute since we long divided anything. And it's easier if we do it with numbers and something familiar before we start throwing weirdo polynomials at you. Because we have added polynomials, we have subtracted polynomials, we have multiplied polynomials. Our bell work is about division. I wonder what we're doing. So we're going to start with dividing polynomials, and we're going to start with a monomial. We're going to divide by a monomial. And I know this is super duper complicated looking, and it's going to take us a second to write it down, and that is okay. I haven't even popped it. Because what we have is this polynomial. It's a trinomial, and it's got 2 variables, so it's a little extra. And we're dividing it by a monomial. Since we are dividing by a monomial, this guy over here, dividing by a single piece, I'm going to rewrite this as a fraction. So I'm going to write this as 24 a to the 4th b cubed plus 18 a squared b squared minus 30 ab cubed all over 6ab. When we are dividing by a monomial, I do recommend we set it up like this. It's very much like that first one we had in the bell work, where we split it up into separate fractions and then simplify it. And that's how we're going to do it when we divide by a monomial. So I'm going to write this again, where I split this up into separate fractions, just like we did on this one, how we split it into 2 pieces. We're going to split this one into pieces. So we're going to have, I'm going to do colors, 24 a to the 4th b cubed over 6ab plus 18 a squared b squared over 6ab minus 30 ab cubed over 6ab. There's a lot of letters and a lot of things going on here. Then what we're going to do is deal with each of these individually. We're going to simplify this left purple fraction here. It's on my screen. You can see the same thing. So we're going to simplify this left purple fraction. So, in fact, let me just look at this guy. When we simplify this, what can we do? Yeah, 24 can divide by 6. What is 24 divided by 6? 4. So my 6's cancel out and this becomes a 4. What about when I have something like a to the 4th over a? I'm going to write it up on the board. I'm going to write this up with 4 a's because a to the 4th is the same thing as a times a times a times a over a. What happens here? Doesn't one of my a's cancel out? So how many a's are we left with? 3 a's in the numerator. So you can do it in here as like this becomes a to the 3rd. And on my b's, what's going to happen with my b's? One's going to cancel out, so it's going to become b squared. And now this looks all kinds of gross and weird. So we're going to rewrite it. 4 a to the 3rd b squared. That is that first term simplified. And then we get to do it again. I'm going to drop this operation. We're going to do the same kind of thing over here on the blue one. We'll take our numbers, we'll simplify our a's, we'll simplify our b's. So 18 divided by 6 is what? 3. A squared divided by a. What are we going to have left? A. And b squared divided by b. B. So one of my a's cancels out, one of my b's cancel out, and the 6 can cancel out. So we just simplify them individually. last one over here. 30ab cubed divided by 6ab. We're going to take each piece. What is 30 divided by 6? 5. A divided by A. They cancel out. And b cubed divided by b. B squared. Yep. A's canceled. And that is our whole and complete answer. So whenever we're dividing by a monomial, we're going to do it fraction style. So if there is not any adding or subtracting going on here, we're going to do it like this. Split it into fractions, cut it into pieces. Okay, we're going to do another one like this because it's a little weird. So this one's just x's. We love that. So we've got 25x to the 4th plus 15x cubed minus 10x squared plus 5x divided by 5x. And what you can do, when you copy it down, you don't have to write it exactly like we have up here. I'm going to switch it back to the view page. You can write it into our fraction first. The 25x to the 4th plus 15x cubed minus 10x squared, it's a 2, plus 5x all over 5x. I just for like for you to see both ways because it gets written both ways on all the things we're going to do. Writing it as a fraction I think is helpful to see where we're going with it, but it'll often be written in a single line simply because it's easier to program in a computer. So then what we're going to do is we're going to split this up into different fractions. We're going to have our 25x to the 4th over 5x and 15x, that's an x, there we go, cubed, over 5x minus 10x squared over 5x plus 5x over 5x. And then we're going to simplify each of these fractions individually. And it takes it from one giant problem into 4 little baby problems. So what is 25 divided by 5? 5. What is x to the 4th divided by x? X to the 3rd, or x cubed. I don't care how we say it. It means the same dang thing. Okay? So the 5's cancel out. One of my x's cancels out. How about 15 divided by 5? 3. And I have x cubed divided by x? X squared. 10 divided by 5? X squared divided by x? Is just x by itself. And 5x over 5x cancels out, which leaves us with what? 1, not 0. 5 over 5 is 1. X over x is 1. 1 times 1 is 1. Okay? So dividing by a monomial, it looks flashy, it looks showy, it looks big and complicated. It's simplifying fractions. End of sentence. It is simplifying fractions, which we've done before. But that only works when we're dividing by a monomial, when we're dividing by something that doesn't have adding or subtracting in it. So what happens when we divide by something with a plus in it? So we have x squared minus 5x minus 36, and we want to divide it by x plus 4. So what we're going to do is we're going to set this up as a long division, just like the one we did in the bell work. So we're going to take our big dude. That's going to go inside the house. We're dividing this by. So we're going to have x squared minus 5x minus 36 all in the house. And we're going to divide it by x plus 4. So this is how we're going to set it up. And then just like we did with that 3 in the bell work, we're going to see how we're going to just look at the x right now. We're going to look at our x. How many times does x go into x squared? So x times what gives me x squared? Not 2. X times what gives me x squared? Oh, x. So we look at our first term of what we're dividing by and the first term of what we're dividing. Ignore the 4 right now. And that's how we decide what goes on top. So x times what gives me our first term? And it's x times x gives me x squared. So x goes on the top. You can also think of it as a teeny tiny baby fraction where you come over here and you go x squared divided by x. And think of it that way if that works better for your brain. However it flows. Then just like we did with that, like the one we took times the 3 and put it underneath, we're going to take our x times the whole guy and put it underneath. So we're going to have x times x, giving us x squared, and x times 4, giving us 4x. That's a plus there. Okay. Questions on how I found either of those pieces for now? Not on the why, just on the how. So then just like we did in the bell work, we subtract between the lines. So I need to subtract these whole things. So x squared minus x squared gives us 0. That's the whole point. Your first term should always disappear. Then I have minus 5x minus 4x gives us minus 9x. And then our last term drops down. And that is our first round of long division, but we're not done because we haven't found our actual answer yet. But questions on the first cycle? Because now we're going to do the same thing. We're going to take the first term in our divisor and what we're dividing by. We're going to say x times what gives me negative 9x. Yeah, x times negative 9 gives me negative 9x. So on the very, very top, we're going to put negative 9. We're going to take this negative 9 times the whole term and write it under here. So negative 9 times x gives us negative 9x. And negative 9 times 4 gives us negative 36. And we are going to come through and subtract the whole line. So be super duper careful. This has a gazillion and a half minus signs. So negative 9x minus negative 9x gives me 0 x's. It cancels out. It's the whole point. First term should always disappear. Negative 36 minus negative 36 gives me 0, because it's negative 36 plus 36. This is where we would have our remainder. We have no remainder here. So our answer here for x squared minus 5x minus 36 divided by x plus 4 is x minus 9. And so these are long and kind of obnoxious. Long division is in fact long. We're going to do another one because they're weird and kind of awkward to get used to. But any questions on this first one? Because that's the whole thing. Okay, we're going to do one more like this. So we've got 3x cubed minus 14x squared minus 7x plus 3 divided by x minus 5. All right, so we're going to set this up in our long division. This is what we're dividing, so that's going to go inside the house. 3x cubed minus 14x squared minus 7x plus 3. And we're going to divide it by x minus 5. So we're setting it up like this. And then what we're going to do is we're going to look at our first term and our first term. So first term of what we're dividing by and first term of what we're dividing. So you can either think of it as 3x cubed divided by x, or x times what gives us 3x cubed. Sometimes it's helpful to write out the little baby fraction. So what is 3x cubed divided by x? X squared, but also the 3. So this, if we do the little baby fraction, this is what's going to go on top. 3x squared goes on top. We take our first terms and we divide them. That's the only thing different between doing it with polynomials and doing it with numbers, is we have to do kind of a baby division in the middle. Then we're going to take our 3x squared times this whole term, the whole guy, 5 included. So 3x squared times x gives us 3x cubed, genuinely the whole point of us doing that. And the 3x squared times the minus 5 gives us minus 15x squared. Because we take our 3x squared times this whole term and write it under here. Then we need to subtract the whole line. And this is where we need to be super careful sign-wise. 3x cubed minus 3x cubed cancels out and goes away. That is the whole point of it. And if it helps, you can write it as 0x cubed. Totally fine. Negative 14 x squared minus negative 15 x squared. What are we going to get? Is it 1 or negative 29? 1. Because this is a double sign. So minus negative 15 becomes plus 15. So this becomes, plus 1x squared. And then I'm just going to drop all the rest of our pieces. Minus 7x plus 3. And that's our first cycle done. Our first term has canceled out, which is quite literally the whole goal of it. So now we're looking at that 1x squared. So round 2, we look at our first term here and our first term here. We want to know x times what gives us x squared, or you can do x squared divided by x, which gives us what? Just x. So our second term up here is just x. So I'm going to take this x times this whole term and write it under here. X times x gives us x squared. X times minus 5 gives us minus 5x. And we're going to subtract them. One x squared minus x squared gives us 0x squared. So they cancel out. If you want to write it, you can. The whole point of it is for that term to cancel out. It should always cancel out. Then we have x, or negative 7x minus negative 5x. What do we get when we subtract these two? Negative 2x. And then we're going to drop down our 3. And since I still have an x here and an x here, I can definitely still do one more round of division. So we're going to do one more round. I'm going to take our minus 2x and divide it by x. And what do we get? What is negative 2x divided by x? Negative 2. So that's what's going to go on the top, negative 2. One more time, we get to multiply this. We're going to take our negative 2 times this whole term and put it way down under here. I'll go back to blue here. So negative 2 times x gives us negative, yep. Negative 2x. And negative 2 times negative 5 gives us plus 10. And we need to subtract our two lines. So we're going to subtract here. So negative 2x minus negative 2x, what happens there? We have 0 x's. They cancel out. That is the whole point. 3 minus 10. I heard somebody start it. Negative 7. Yeah. 3 minus 10 is negative 7. This is our remainder. So I'm going to give us a little bit more space. So when we write out our whole answer, that's not the button, we take our answer that's on top, my 3x squared plus x minus 2. That was our guy on top. And just like we did in the bell work one where we had our remainder, we're going to take our minus 7 over what we divided by, x minus 5. So I got to zoom this in so I can actually write. We're not going to have tons that have remainders. Like, we're just not, because it's kind of mean. But I wanted you to see what that's like, because if you look in the book for extra problems, or if you go online, or if you do pretty much anything other than exactly, I think I might even put one on here, exactly what we're doing here. No. If you do anything other than my worksheet, I didn't even give you a remainder, you will see them with remainders. Anything other. These ones should all come out nicely. If you get remainders, something went sideways. Okay? So they're kind of gross and they're super long. Long division isn't that enough. So I'm going to give you homework 4-4. The front side has monomial division and some long division problems. The back side is what we're going to talk about tomorrow, because I wonder if there is a shorter way to do this. Oh my gosh, long division is so long. Okay, so tomorrow we'll talk about a different way to divide that's based off of this but takes way less writing. So that's what we're going to do tomorrow. So this is homework 4-4. Our chapter test is a week from today. It is next Thursday. So I think we're only going to have one more assignment. And I'll give it to you Monday. Okay? So that'll be it. We're almost there. We're almost there.